before we move on to the next lab, just a quick recap of what we tried to do in the previous lab on Blackbuster. So first, we had an external report which mentioned code signing certificates and samples. We were able to acquire those samples, download it to our malware corpus. We were then able to extract the certificate blueprints. Sorry, I meant thumbprints, and we started using that to hunt within our own corpus or our own environment. We didn't find any hits. We then switched to external hunting where we queried the Malware Bazaar API and we found additional samples that were matching those certificate thumbprints. We were then able to then apply a layer of enrichment on top of them based on the tags and signature to then figure out if those were indeed related to the Blackbuster ransomware group or not. And just gonna quickly show you, but there were a couple of questions as well. So here we can see for the lab 1, if you scroll all the way down, there were a couple of questions. The first one was around rule number 2 and how we could have improved it. So this is quite debatable, and you could have told me that, oh, Yash, but like I don't see any issues with the rule, right? And what I'm about to say next is also arguable, right? Here we are directly trying to probe for the thumbprints for the certificates, but it would have been nice or a little bit more systematic and sequenced if we probably looked at whether the file was signed in the first place or not. And we could have done this based on the number of signatures, right? The PE signatures. If it is more than 0 or at least 1, in other words, then you start checking for those the presence of those certificate thumbprints. The second one is something that requires a little bit of OSINT, and if you have a little bit of knowledge around Blackbuster ransomware group, it might go your way. So it was mainly around this particular output, and basically we're trying to figure out if this is still related to the Blackbuster ransomware group or not. So naturally over here, these are the tags and signatures from those 66 samples that we extracted from Malware Bazaar. So here you can see a lot of Pikabot being mentioned. So Pikabot is one of the loader malware being used by Blackbuster. Here we can see a specific C2 framework, Arch Client 2 mentioned. If we keep going through here, you see a domain as well, vendorcompany.com. Can keep going through, and then here we see your code signing certificates and some IP addresses being mentioned. But here you can also see the mention of TA577. They're essentially an initial access broker who are known to distribute Quackbot and Pikabot, and they have been seen historically working very closely with the Blackbuster ransomware operators. So all of that is kind of tying into what we were trying to figure out if this was related to the Blackbuster ransomware group or not. Fantastic. Now let's move on to the next lab that we have over here, which is on Kimsuky, a DPRK cluster. We're going to be focusing on a custom malware as a human fingerprint, and we're going to be having this one file hash that we're going to be leveraging as well. This is the starting point for our investigation, and we have some idea that it might be related to Kimsuky. We have a scenario in place, and we know that the file is an LNK file or a Windows shortcut file. And additionally, and more importantly, there was a very similar sample mentioned by this particular researcher. So we were able to reach out to him and get a different sample. And here, quite unusually, you can see there is like a big blob of PowerShell commands being executed. And at the same time, here you can see some abnormal gap between your arguments and the PowerShell commandlet. So let's see how we can create Yara. And before we move into our virtual environment, let's take a look into the file sample. It is only natural to drop it into VirusTotal or VT and just seeing if we can get any analysis out of it. For starters, we can already see that the top threat label is Kimsuky, and we can already see like a few of the vendors are detecting this indeed as Kimsuky. It is an LNK file. It is 1 megabyte in size. If we go to the details, we can see some metadata property. We see some alternative file names, and we can see the creation date as well. And also we can see some of the command line arguments from that screenshot, which might be familiar to us. And actually, in the community, you can also see where the malware was mentioned. Here we can see a particular mention of an article referencing a 0-day in this particular widespread APT campaign. We see some other bits. We see another report being mentioned. If you keep scrolling down, you might also see some Yara rules. So here you can see some Yara rules also firing on it. Interestingly enough, they are not attributing the LNK to Kimsuky. It could be for a variety of reasons. It could be just because they might be tracking this internally and for OPSEC matters. So we don't know at this point, right? Now that being said, let's go into our VM. We know that the file hash starts with FE156. So let's navigate to that file hash. So it's under our, 1 second. It's within our corpus, malware, Kimsuky directory, and then we have, we can just run a file on FE156, auto-completed. Here you can see it is indeed a Windows shortcut file. We can see some parameters. It has command line arguments, some metadata property associated with it, which is fine. We could also try running strings against it. It is also quite conventional as part of your Yara workflow to running strings against it. So let's just do that. So over here, we can see some weird strings, some padding perhaps, but we don't see much over here. Next step is typically to check that in hex. Now you could just use the command line xxd utility for hex viewing, but I'm going to be using a GUI based hex editor because I'm used to GUI based hex editors, especially when just doing malware analysis on a Windows workstation virtual environment. So we are gonna be using imhex. So you just type imhex. It's gonna open up. Just give it some time to load. Right, let's open that file, E156. So now we are prompted with this particular pattern that imhex has found, which is an LNK pattern that it would like to apply to this file. So let's just go ahead and say yes. So essentially, it's going to try its level best to start parsing that file structure because it has recognized the file as LNK, which might probably help with that analysis. Who knows? So we're just going to give it some time, let it do its thing. It's going to move to the hex editor and just going to zoom in a little bit. So over here, we're still waiting for it to do its magic. It's still evaluating the thing. In the meantime, we could probably get the show going. Just start creating a Yara rule, just keeping it ready with the metadata and other things. So there we go. As you can see, the file has also loaded. Right. In that case, let's just go back to the hex file again. If you keep scrolling down, here you can clearly see the /c command, the PowerShell commandlet, which we saw in that screenshot that the researcher had shared. And if you keep scrolling up, you can actually see, well, actually, there is something that abnormal gap is between that and the string blob over here. And because the file has been parsed, here you can see it correctly identifies some of the properties. So here you can see it's an LNK. It has a shell link header, and then it has a lot of wealth of metadata property that we can look into. We have creation time, access time, write time. If you actually click on this, you can see it's actually a string structure kind of a thing going on over there. We should be able to locate it if I'm not mistaken, probably here in the string data property and somewhere here. So if you click over here further, here you can clearly see that that string blob is actually part of this string data over here, as we can see highlighted in that color. So it's quite useful, helpful. We already know a good starting point would just simply be the LNK header itself. So we could just use that. And again, like there in your resources. It's there in the cheat sheet if you have forgotten what the LNK file header looks like, or it's just a Google search away. Right, so I'm just gonna take that as it is. Just gonna copy it, and then now we're just gonna start building our Yara rule. Right, I'm just gonna call that head, and this is gonna be a nice segue into hex strings as well. Just dropped it in. It just takes time to paste it, by the way, when you are copying from the hex editor. Let's just start by naming this group. So APT actor, we know the country code, so DPRK for Kimsuky. Kimsuky. It's a malware, it's Windows, it's an LNK. We don't know the name of the malware or the type, so I'm just going to leave it as unknown. And then here we're just going to be making use of probably strings, so I'm just going to stick to that. And here I'm just going to put detects LNK used by Kimsuky, because that is all we know till now, right? Without any further context. Here, ideally, I would have just probably dropped the file hash in. So let's, we might need to open up another window. So if I did SHA-256 sum and then FE1, actually that wasn't required because the file hash is the name, but anyways, we have the file hash here now. I'm just gonna take that, paste it in. Nice. So at least the metadata is ready. Now, what we need to do is we need to figure out how we can capture some of the interesting characteristics from that file. And over here, I think this looks like some solid metadata property, right? It says type text document, even though it's an LNK file. And then we see something being mentioned over there. And then naturally the suspicious PowerShell commandlet. Now here, also more interestingly, and as seen in the screenshot before, here we see this blob of strings. So here you could have argued with me again. You could have been like, oh yeah, fantastic. We have the command line, sorry, the PowerShell commands, and we have this string blob over here. We can just use them and be done with it. You are absolutely right. That can be done. But if and when there's an opportunity to do something a little bit more specific with our rules, we should absolutely embrace it. And we're going to try our level best to actually calculate the blob space between those two constants. So how do we do that? Coming here now, you can see you simply pick that, select it all the way across, and it just selects the relevant hex bits, which is quite handy. So now you can just go ahead, copy it, go back into our rule over there. Alternatively, you could have probably taken the text string itself in those double quotes. You could have done that, and this would have been a wide string because as you can see over here, it's been padded with 0, 0. So it is very likely a wide string. So I'm just going to call it str blob. Actually, let's just call it meta for metadata. And the next one, I'm just going to call it power for like PowerShell, PWR. Okay. And it's going to be a string, same similar hex convention that we can use. Again, you can completely experiment with it. That's perfectly fine. I'm just going to do that. I'm just going to quickly make the header, first of all. So that header thing at 0, and then we can check for other conditions later on, right? Awesome. Now what we have is that blob-like thing over there, scrolling all the way down, and then we have this, right? So we can pick from, we capture that slash as well. That's why. There we go. So I can just pick that one. I think that should be sufficient until that. Just gonna quickly pick it up. And now we have at least our strings under consideration, which is awesome. Now, naturally, as I mentioned, a simple rule could have been, oh, just give me PWR and meta, and then we are done with it, right? So this is a perfectly fine rule. So if actually let's just try running that rule, right? I'm gonna go back now so that we can run it from the parent directory. So Yara rules, it's called Kim dot Yara, and then we're gonna run it against our corpus, malware, and Kimsuky. So if you run it, you can see it matches against that file, which is what we would expect right now. 1 second, please. Yeah, so it is indeed matching against that particular file, which is what is expected. Honestly, I would have expected that to match against more files. So I'm not exactly sure what has happened over there. Just gonna take a quick pause to figure it out, and I'll be back with you guys. Apologies. Actually, it only is matching against that one file, so there was nothing, well, wrong with the rule itself. So I think it is perfectly fine. So let's just crack on. So going back to our previous rule, I'm just going to clear things up and then just run it again. It matches against that one file, which is fine. Now time to actually calculate the hex block that we have. So over here now, in order to do that, we can just use relative offsets in Yara. So all you need to do is figure out where this particular string, at what address is this particular string starting at, and then we're going to figure out where this particular string is starting at, and then we can just calculate that difference using a very simple hex calculator. So let's get that address, right? So over here, if I click on that, that's really the string of interest, and that's what we have used in our rule as well. Here you can see it's an intersection between 40, and here you can see E over there. So it will then become 4E based on that convention. So what I can do is just store this somewhere as a metadata. So I'm just gonna comment it like that. 4E is one of the addresses that we have. Then the other one would be coming back here. We can see over here, let me just click that a slash symbol. So here it would become 4D, and then this would become 2, right? So 4D2 would be the other one. So if I go back, so we have this, and we have 4D2. Oh, I think the previous one would have been this one over here. Yeah, so all we need to do is just simply that would be a 0. So we just need to subtract the 2 and find out what is going on over there. So we can just make use of the hex calculator within sorry, just the calculator over here within our VM. We open it up. I think this has already changed to programming, but initially it would have been like this, basic. So you just need to go there, change it to programming, and then come here and switch to hexadecimal operations. And then now you can just attempt to enter those values. So we would enter 4D2 first, and then hit a minus because we're trying to find that space in the middle, and then 04E. So don't worry, in the lab guide, this has been explained in a little bit more depth as well, and the logic behind it. So you get 484, right? And that 484 in decimal becomes 1156, okay? So I'm just gonna keep just a track over here, 484. and then 1, 1 by 6. Now, what we can do is we can use the at symbol to get those relative offsets. So now I'm telling Yara that actually, wherever my PowerShell command line is, right, it should occur relatively to my metadata, right? It should be wherever my metadata is, in addition to that decimal spaces that we found. So if this rule is correct, it should then work. Let's try it. Okay, it did not like that for some reason. What am I doing wrong? PowerShell equals. That does seem like a correct rule, by the way. Yeah, that's the correct offset based on the rule that I had initially. Nothing seems to change over there either, apart from selecting 54. Oh, I see. Actually, one character is missing. The T is missing. That's what has happened. That's a typo on my end. My bad. So over here, when I was selecting T, I accidentally selected from here. So I left out the 54 over there. That's why it's not working. So if we selected 54, save the rule, and then run it again now, hopefully now it should work. Perfect. We have a hit, right? So now what you would like to do is check your broader corpus and see if you're able to find anything or not. And let's exactly do that, right? So over here, sorry, it's a recursive flag I have not used. -R. We're going to run against the entirety of the malware corpus. Let's run it. And now we wait. And I'm just going to take this time to move the dogs. So 1 second, just bear with me. Be back. 1 second. Apologies for that. Dog had to move. Right. So as we can see over here, we can see matches against some reports as well from the APT collection of VX Underground. So here we can see, if I scroll all the way up, here we can see analysis of North Korean Kimsuky targeting victims. If we keep scrolling down, we also see that 0-day article being mentioned in VT. Keep scrolling down, we see some other mentions as well, which is, well, interesting because we see some matches against our Kimsuky directory as well, which means we are definitely on the right path. So hopefully that was an interesting exercise where we leveraged relative offsets combined with those unique strings to have been able to build that. And yeah, hopefully you guys found that helpful. And up next, there are a few tasks related to this particular lab. So hopefully you guys are able to also do that. And up next, Kowalski is also waiting for you in task 2. This the task on penguins, which is always my personal favorite. So hopefully I will catch you guys there.